slowly moving over the landscape, and all these poor animals in its way running for their lives.
Herds of lumber herbivores run from the walls of flame, but there's no escape. Their spikes may protect them from predators, but they only slow them down now.
Anything in its path is going to be immediately wiped out.
For weeks, even months on end, the fissures spew lava onto the surface. The molten rock destroys anything it touches, laying waste to the landscape.
We have no human understanding or connection to an event such as camp. Nothing like that has happened since humans evolved.
Animals evacuate ground zero. For those that used to live in what is now the east coast of the United States, there is no home left. As the exodus continues, one type of animal seems better equipped to adjust to the changes. The earliest dinosaurs, like Styracosaurus. Styracosaurus and others like him are just a few feet tall, but they're unique in this world, the only animals to walk upright on two legs.
Being bipedal is a very rare thing to do. Mammals do it in terms of humans and in terms of kangaroos. But dinosaurs were the first ones to really take advantage of running on two legs.
Styracosaurus is a nimble hunter in a world of lumbering quadrupeds.
What a shock for all these animals. Gee, I've been on land for 100 million years. I've never seen anybody walk around on his hind legs before. It would have looked maybe ridiculous, but maybe not, once that thing started running at you at high speed.
While far from the T-Rex of its day, its prowess grows as larger animals continue to struggle.
We had these early dinosaurs not yet big enough to take down one of these big reptilian types, but certainly big enough to take down their young.
But even this nimble predator cannot outrun this devastation. The eruptions continue. Deadly side effects begin to take hold on every corner of the globe. The Earth has been set on an ominous path. How long before the blue planet becomes the red planet? For decades, horrific volcanic eruptions have spewed vast amounts of lava onto Earth's surface. The massive eruptions have a toxic effect on Earth's atmosphere.
The volcanic eruptions don't just produce lava, that's the most immediate consequence. They also produce a great deal of gas, which is dissolved at high pressure within the magma. As that comes towards the surface, the pressure reduces and this explodes out of the lava into the atmosphere.
Millions of tons of toxic gas are pumped into the air. The amount of carbon dioxide in Earth's atmosphere increases exponentially.
Let's take an analogy here. Let's go back, and instead of these volcanoes going off, let's say that we build 10,000 coal-fired power plants. Line them all up, tons of coal coming in, plant after power plant after power plant after power plant, all with their chimneys streaming up gas into the atmosphere. That's exactly what's going on with these magmatic provinces.
Temperatures skyrocket. It's unbearably hot. Even animals that live in the water, like Rutiodon, are affected. They lie in the shallows, trying to stay cool, but they must venture up onto land to lay eggs. It's a fatal flaw that dooms their species.
Some reptiles today, heat actually determines the sex of the embryo. So I could imagine back in the Triassic if some of these animals had this type of reproductive strategy where sex determination was based on temperature. You could drive a species to extinction by producing just males and males and males and males, and all you're producing is males. And so that would be a devastating way to kill off a species.
It's also far more difficult to stay nourished. The heat saps their strength. Insatiable hunger drives them to turn on their children, as crocodiles are known to do today. Cannibalism might well seal the fate of this species. The slow death march of extinction goes on. The sudden warming of the globe ushers in another catastrophic side effect. Oxygen levels plunge to record lows.
There's roughly half the concentration of oxygen in the atmosphere that we have today. So it would have been much more difficult, given the same respiratory apparatus, for an organism to breathe in the late Triassic than it would be for the same organism today.
In what is now the southwestern US, a herd of Desmatasuchus forages for food. The air is thick with carbon dioxide, the sun unbearably hot. Trying to breathe here is like trying to breathe at the top of Mount Everest. The big armored beasts have never feared a predator. But now, their greatest enemy may lurk within their own bodies. Their primitive lung system, combined with a sprawling posture, makes it difficult to breathe and move at the same time. Desmatasuchus saunters with a side-to-side motion, much like a modern lizard. As it goes, that flexion expands one lung and compresses the other, a trait called carrier's constraint.
Animals like lizards and salamanders that move in this sprawling way, where the body has to swing from side to side a great deal, that actually limits the capacity of the lungs and the capacity to breathe.
The low oxygen is also wreaking havoc on their reproduction rate. Conditions thrust the developing embryos into a lethal catch-22.
Now, if we go back to the Triassic and oxygen levels are equivalent to being at 14,000 feet, your reproductive system is going to be vastly challenged. An egg has to have oxygen coming in through it, enough so that the embryo can develop. At the same time, an egg also has to hold water in. And so this is really opposite aspects. You have to have a lot of holes in your egg to let the oxygen come in, and the lower the atmospheric oxygen, the more holes you need. But on the other turn, the more holes you have, the more water can evaporate out, causing death as well.
With each passing year, fewer Desmatasuchus are hatching. And those that do are not growing as large as previous generations. Their population will slowly ebb away in the coming years. Styracosaurus is quick to take advantage of the weakened Desmatasuchus. For Styracosaurus, walking upright eliminates the problem of carrier's constraint that plagues Desmatasuchus.
Once the limbs go straight under the body, they're not interfering with the internal organs in the torso. And that allows the lungs to expand more, to operate at a higher level.
Scientists theorize that they may have had extra air sacs that continuously circulated oxygen through their respiratory system. Today, this is the same feature that allows birds to fly at very high altitudes for extended periods of time.
The dinosaur lung is the same as a bird lung. A bird sitting here right next to me, breathing the same air I am, is going to extract about 1/3 more oxygen than I do. So you might say that, gee, this is a coincidence. Oxygen drops to its lowest point in 500 million years. The most efficient lung the world has ever seen appears. But evolution doesn't usually run from or derive from such coincidences. This really seems to be cause and effect.
A full-grown Desmatosuchus was once too large for Styracosaurus to take down. But now, this early dinosaur feasts on the struggling herbivores.
It would have been really unfair, really. You've got this creature which can run rings around you, whereas if you're the prey, you're trying to run away from this thing and you're gasping for breath.
Centuries pass. In North America, where the rifting first started, it seems that new fissures are erupting every day. The face of the supercontinent is melting like hot wax. The volcanic stranglehold tightens with no end in sight. The Earth is morphing into a new world. But will it be a world filled with life or death? Heard the heavens fill with shouting, and there rained a ghastly dew. Alfred Lord Tennyson, 1842. "50,000 years into a terrible mass extinction, our planet is transforming into an alien world. Barren landscapes, skyrocketing carbon dioxide levels, thinning air. The daytime sky is tinted red. It's a scene expected on Mars, not on planet Earth. Global warming has turned lush jungles into tinder-dry forests. Wildfires are commonplace. In the Triassic world, these fires will burn until there's nothing left to destroy.
From space, it would have been fantastic. You would have seen this enormous black area, and perhaps even the forest fires, because as this stuff pours out, that tropical vegetation of the Triassic is going to catch fire. And so it's like a huge spreading cancer in the surface of the Earth.
The fires add more pollutants to the air, only intensifying the disaster. Rolling clouds of ash cover the landscape. Burying thousands of hapless victims. No one is spared. Rutiodon seeks shelter from the storm, but their homes offer no protection. The water in Pangaea's lakes and streams turns to a cement-like paste. For the Rutiodons, the results are dreadful. The ash mixes with water vapor in the atmosphere, resulting in acid rain.